We are. Welcome, everybody. I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. And we are here at Aruba Atmosphere. We have been enjoying this conference this week. It's great to be back in person. It's great to see how things are doing and going with this new world of hybrid events and in-person people. It's great to see so many people here live in Las Vegas as well. For what it's worth, the Aruba folks have told me that there are more people here this year than there were in 2019 before the pandemic. So that's a pretty good, successful conference right there. We have gathered a bunch of our field day delegates here. These are folks who are independent technical influencers. They are folks who have blogs and podcasts and so on. They like to discuss networking and mobility and so on. And we're hoping that we can get some interesting conversations here about the state of Wi-Fi and how things are going in the enterprise and anything that they've learned here at Atmosphere 22. So to kick things off, frankly, from my perspective, I think that the most important announcement was the location-aware Wi-Fi. I'm going to throw it out to the panel here, and frankly, actually, I'm going to pick on. I think I'm going to pick on Keith first. Let's talk about this. You and I were talking about this earlier. Tell us what was announced and why do you think it's important?
What was announced was newest APs, the 6 EAPs, have a GPS chipset built inside them, which allows them to find GPS even if they're deep inside of a building and get a lock. The reason why that lock's important is in order for any type of location tracking to work, you need to know where at least one thing is and then the differential between those. The example they used was latitude and longitude. It's fairly easy to find your latitude on the Earth. We've been doing that for centuries. Longitude needed a fixed point, Greenwich Mean Time, and then the time difference between where you were. And between those two times, you could come up with an absolute place where you were. And then anything from that is the differential. And so now that Aruba's APs will have these, and by the way, if you've already got one of the 600 series APs, you already have the GPS. It's already been in there. You can now, with the new software they've developed, allow them to find themselves with latitude and longitude, and then using a different thing that came from 802.11mc, which is called FTM, Find Time
and Measurement.
Measurement, yeah. It allows the other APs to talk between themselves following a standard protocol to say, can we talk to each other and figure out the distance between each other? And from those locked locations, all the APs in your environment can have a location locked within sub 1 meter, which is extremely valuable in that we don't have to go back and physically place them on a map. One of the things I like best about this is that it's not based on a map. It's based on standard latitude and longitude coordinates. Now, of course, to actually use it in the real world, you're going to put a map underlay. But we've had some difficult times getting different maps and then trying to tie all of your location tracking to a map versus a standard latitude, longitude. So I think it's a great new change. I'm not really happy about seeing some of the marketing things like indoor GPS, because it's not indoor GPS. But what it does do is fantastic. So I think that was one of the strongest things that I saw in the presentations, and they did a great job of explaining why you needed those locked locations and then the benefits you get off of that.
Yeah, one of the things I did want to say is that technically it's not just a standard GPS chip, it's GNSS, I believe, which is, it allows you to get more than just the North American, satellites. You get any of the well, not any, but I don't know exactly what they are, but a series of international constellation satellite systems that are out there. So you actually get a lot more data. So one of the, people were asking how is this going to work? GPS doesn't work indoors, and technically you are correct, but that's not the point. The point isn't to follow you around. The point is the 6 APs with this GNSS chip will be able to find themselves, they're stationary, right? Because they're mounted somewhere, and they capture that data, but then what they're doing is they're leveraging the 802.11mc to do that time of flight measurement, so that they can use the non-GPS enabled APs to kind of validate each other, right? So the GPS gets GPS coordinates to say, okay, this is basically where we are, and the internal APs without or not internal, that's not the right, the APs that don't have the GNS chipped in them will use time of flight to kind of bring that in and try to reduce that error. And then over time, as the GPS, obviously indoors, it's not going to be that great, so it takes time. It has to keep going, and it has a margin of error, and it can reduce that margin of error by time, getting more data, and the information it's getting from the non-GPS or GNS enabled APs that are doing the flight of time or time of flight type of measurements. And all of that, it gets tighter and tighter and tighter.
And I like you said, it's about time. It's not instantaneous. It's not for mobile.
Right, right.
And for people to understand GPS, that they're celestial, you don't have anything underneath you to help you lock that in. But having the other time of flight information can help lock that in. So we had a session with Stu and Chuck, and it was nice to see the progression of how they learned to do this. And then once you know how to do it, what I like about it, one of the best things about technology when you find a new one is like, that's so cool. I wish I learned it. I wish I did myself. Because as soon as you hear it and you figure it out, it's like, of course. And then everyone's going to follow along.
Yeah.
One thing that I found interesting in the demo this morning, if you take a look at that map, what they did, they auto-placed the APs and then they located an object within the APs. Imagine trying to do that manually, placing those APs in a room like that, where you have virtually no hard things to measure against. You got piles of chairs and stuff that just got put in there 2 days ago. The map's probably not perfect. That takes all that off the table. The APs are where they should be in relation to each other based on that technology. And that makes the location a whole lot better. I mean, I was thinking of it when I learned about it, I was thinking about it in a traditional building with hallways, doors, whatever. But it really, I think, comes to life in a big open room.
That's the worst possible place to try to show it off, yeah.
Yeah, it is. And it's the worst possible place as a network administrator to have to place APs on a map, because you have nothing to go on that's concrete in a lot of cases. So
I think one of the interesting conversations we should start having and experimenting with this is, what is the environments that this really works in, and what are the environments where it doesn't work too well? Because clearly it wouldn't work very well in the basement. But one of the things that struck me is in places like hospitals, where you're already tracking and deploying your Wi-Fi networks for location services, you're going to have your access points around the perimeter of the building. And so your ability to find those 4 anchor access points is going to be very, very good. And therefore, in those environments where you're already worried about location services in your business, this is really going to add a layer of accuracy. And I think you can, I wouldn't like to say guarantee, but my gut tells me you could almost guarantee that this would work in that environment, because you've got them in the perimeter of the building. In environments where you're not doing that and your access points are more inwards, then I think it would be interesting to see what kind of accuracy you really get. And I think us as professionals in the market, I think this is going to be, we really want to get our hands on this stuff and start playing with it, so we can start advising our customers on, what are the right deployments. And indeed, when we're actually doing our site surveys and our plans, do we want to start positioning our access points a little bit differently so we can take advantage of this?
Oh, by the way, the demo today was using Wi-Fi 6, not Wi-Fi 6E APs. They didn't have GPS in them. So this was just the FTM measurements allowed that level. So even more impressive.
yeah, relative to one another, but not anything else.
Yeah.
Manually.
Yeah, so that was even more impressive.
I think it's important what you pointed out there at the end, that there were 500 series APs this morning, and both the 500 and the 600 series APs fully participate in the self-locating scheme, even though there's an extra step for the 500 series because they lack a GPS receiver. Ideally, in the sort of deployment we had in the demo this morning, when you enter though, when you place manually those 4 ones around the perimeter, you would place them with respect to latitude and longitude as well, so that everything would locate themselves in the same scheme, but you'll have to do that. But it's just, I'm so grateful to you all for have listened and to be now able to share this view, because I think, it's not just an Aruba story, it's a story for the whole networking industry, and also sort of independent of that, the location services ecosystem. It's really
Big change.
really great. Thank you.
And something I totally missed was the reason behind it. In 6 gigahertz, if you want to go to standard power, and we don't have that yet in the US, actually we don't have it anywhere in the world, but we plan on having the FCC approve standard power APs, they need to self-locate. So we now have them that actually do that already. So anyone who's CBS certified has already understood the process you have to go through on the CBRS side. We're going to have the same type of thing in the 6E, but they'll need to go talk to an AFC to make sure that they can use a frequency, and that's a minimum requirement, and we've now seen them live working. In fact, Eddie, you saw the session where he pulled it out, and you got to look right and see the actual antennas where they are.
Yeah.
So given the technology then, I want to ask if we can maybe talk a little bit more about the applications for this technology. So now we know how it works. Go ahead.
Yeah, that's actually what I was just going to comment on. We were talking about it at lunch a little bit. If you look at what you could potentially do with this, the impetus of it, right, was to have and make sure that the reference points we were using for location were well known, right? So it's kind of changing the beginning to an answer, the beginning to a solution, right? But I think once we know that, looking at what we could potentially do with that or what would be useful, I think all of us have probably gone into environments where, there's been a regime change and documentation didn't exist and people don't know where access points are, right? And I think there's going to be a portion of this that, is almost like self-documenting in the sense that it's going to, it does show up on a map, and at least there's a reference point and there's a way to find that information that may not have existed without that technology, right? And it really would require not only going through with, a survey tool, but then, if something's above a ceiling, like trying to actually find out where that AP is, you should be able to get much, much closer.
We call that prairie dogging.
Yeah, exactly. It's very time consuming. It's very expensive, right? To have a customer, I know I've dealt with customers that have thousands of APs, and they could, they might be able to tell you where 10% of them are, right? I mean, it'd be nice if that was more automated, and now going forward, that should be the case.
I really liked in the demo this morning how they used this to then find that water bottle, right? I thought that was pretty cool. So it's showing you how you can actually then apply this to providing more accuracy to the client. The thing I hated, right, and took real exception to, was when they implied, or perhaps not in the keynote, this was perhaps in other conversations, was that you could use these finite measurements to the client. Because I just don't see how that could work, because it's a fairly chatty protocol. You've got to go backwards and forwards. The client would have to talk to multiple access points on different channels. So it has to tune itself to a different channel, have a little chit chat, assuming that it can get, that it's not so crowded that you can actually get to transmit, and then tune itself to a different channel and start communicating while moving. Right? So I just don't see how that could work. But I really think once you've got accurate access point locations, then I think the client can do things like triangulation and things like that, being given that information, like a beaconing type of information to the client. And I think it's really important to kind of couple these techniques and not to imply that this naturally progresses to a moving client. So I did take a little exception to that piece.
But they did use tile. They did use a tile rather than some unique Aruba-only thing. We have tiles on our keychains and all sorts.
Yes.
If you have a wife like mine, you put them on everything. And
I guess
they found them right away.
And because you kind of left it behind, it was kind of pseudo-fixed for that period of time, right? As opposed to a client that's sort of like me walking through this casino, trying to work out where I am and where I should be going. That kind of location services. I think it's applicable for potentially some, like pseudo fix. But the minute you go mobile, I just don't see how that could work.
Well, and tiles, what do they beacon once every 15 minutes or so, 10 minutes? I don't know. There's a,
I think it's a little faster, but yeah.
is it, I mean, air tags are very slow. I know that this is not part of that, but as far as BLE devices that beacon to be located by other things, there is no moving aspect at all. It's a slow interval of when it talks and is seen by the network. So
If I'd taken that water bottle and thought, wow, it's so precious to have that water bottle, and sprinted out of there, I could have kept it, right?
yeah, but that's because of the limitation of the way tile works more than this
Right.
technology.
Oh,
But yeah, I get what you're saying. But yes.
So what other use cases are there for this technology? So you know where all your APs are very, very closely. What can you do with that, Eddie?
Well, forgive me if I'm wrong about this, but during the presentation that we were given, there was some talk of that partnerships on a technical level with mapping companies like Google, Apple, and Bing, so they didn't mention this, so I took from that the implication is possibly in the future, as there more integration comes, I'm assuming, tell me if I'm wrong, an organization like, say, the Venetian could submit maps to Google and say, these are our maps, these are the floors, and you could literally do wayfinding in the future using Google or Apple or Bing.
Yeah, microphone, sorry, for the video audience.
That can be done today within Google Maps or Apple Maps or Bing Maps for a lot of locations that have already uploaded their indoor maps. And I don't know about the Venetian, but it's certainly possible that they could do that. The nice thing about that is that once it's done, the location of the access points, because they use the same reference frame, are immediately applicable. So any application that called the operating system to find out where they are and then tries to place you on a map would be orienting in whatever map was on that space. Could I come back to the point that you raised just a moment ago about the tracking? You're right, absolutely. Find time measurement, because it's a bidirectional, I mean, there are bunches of measurements, like hundreds of measurements have to be taken by each side and by each AP to the client device before you end up with a location. And that means it's probably not a very good technology to use for everyone to find their way to the concession stand at intermission or something like that. It's not so bad for tracking around. We can get 1 Hertz updates for an individual device when it's moving through space, and I showed some demos of that with an Android device. But it's typically not what you would want to do for that sort of real-time tracking application. There is a roadmap, however, towards things like single-sided time measurements. Now, clients can't do that, but the network can. Where the network just sends out a signal, or any of the signals it's already sending out, a probe request, and waits for a probe response and does the measurement off of incidental signals that are already being sent rather than generating ones specifically for this. Now, it will never quite be at the point like Bluetooth is, where the Bluetooth RSSI measurements are completely passive. And you're just listening for what's in your environment. But depending upon the use case, a wide range of chatty or less chatty technologies can be used.
I'm thinking when you said that, one of the applications might be like in warehouses and factories where you've got robotics, forklifts driving around and things like that. Maybe there's a real nice application there for things like that.
Yeah, well, tying in robots and slow moving, if you think of your favorite robotic vacuum cleaner driving around, if we can figure out where that robot is, we could automate it based on one of the comments that came out of the keynotes, tying that into surveys. Now you could automate your surveys with little robots that are driving around in relatively slow motion, and they could survey and measure all of your heat maps and your signal strength and your spectrum interference, all of that, and just let them run overnight, right? And read the data on the next day. So I think that becomes a really interesting use case.
And of course, that brings up another point that came up during the keynote. I don't know who said it, but somebody said something about surveys being dead.
They said no more surveys.
Are surveys dead?
Apparently.
Well,
That's what they told
robots
us.
can take it over. It's maybe for humans, it's no longer required in all environments.
I think they're as dead as 2.4 gig.
Yeah.
one of the other applications we talked about is more in the automation space, and it's still core to IT, but I think also there's a, knowing where access point is, if I'm operating a large network, I've got a bunch of sites, that kind of thing, and I can just ship an AP to a location, or if that AP somehow disappeared from a location, I mean, there's potential for automation there to either auto provision it or de-provision it, or prevent it from reconnecting the network based off of its geolocation. Should it have a GPS device, right? And maybe there's some additional applications where some use case like the micro branch router. Maybe maybe I only wanted to operate in like a geofenced area, and I could only connect from a geofenced area. There's some use cases like that you could potentially do with having GPS data on an access point that's VPN back into the environment. That might be interesting.
I do want to mention that, Aruba didn't discuss it this morning, but I think it's really interesting that they're fine-tuning their neighborhood report. So that will give much better performance in terms of handover and other things. And I think that's a snippet that's really important. And I think there might be some other applications there as well, just to fine-tune and make our Wi-Fi networks a little more efficient. I thought that was interesting.
And I think the net result will be we can, I don't want to make this sound bad, we can start to trust visual RF more.
Just digging in on that no more surveys a little bit. I don't want to beat that up too much. Obviously, a lot of folks make a living out of that. But one of the things you guys haven't talked about was the UXI agent running on a device. It was also demonstrated that that could now kind of tie in to location. So I think in the demo, they showed a roaming issue, and you were able to pinpoint exactly where that roaming problem was. So I could potentially, see this building towards no more surveys. Obviously, it's not there now, right? But this whole process of walking around with a laptop and gathering data and so forth, and then 5 minutes later, the data is stale because, the Wi-Fi environment is changing so quickly, seems quite archaic. So perhaps if you had, an app on the client that's doing these site survey types of things, running synthetic transactions in the background and so forth, you could potentially with this application have, 7x24, 365 site survey happening, just with your client devices. So I guess my question is, what are your thoughts on where that could potentially go?
I like your idea. I think it's a great idea. I think the downside is, like any solution that requires an agent on a client, there's this wall you just bump into about putting the agent on. There's so many things we could do if we could have agents everywhere.
Yeah, and I think you almost need an excuse to put the agent on the client, but maybe it helps with authentication or something. Now you got the agent on there, and it can do these things in the background. Anyway, I thought not a lot of light was put on that particular feature of tying in the UXI to location. I thought that was really cool.
Yeah, so I think on that front, there's a few things. And if you take a space that's, well, it's not like a public space like this, but let's take somewhere where we have a lot more control, like a healthcare environment, and the phones belong to nurses that are walking around and giving care, and so they're either, that organization owns those devices, right? I do think having an agent on there is going to change the game a lot. There's a lot of things we see, even with any one specific type of phone, you get different variations in how that type of phone, if I took 10 of them, I'll probably have 10 different results in what I see on the network, right? So getting real world input there, and then also understanding, Dr. Selder mentioned the neighbor list and 11K, and in hospitals, sometimes the network is so dense, and the way that 11K has been implemented, we've actually seen it cause problems where there's more APs than are actually shared with the phone. And so it'll scan that list a couple of times before it tries to find something else. So getting better data to the device to help it make roaming decisions, and getting better feedback, better telemetry from the device in terms of what it's seeing, I do think that would offer a lot in terms of trying to really understand where the problems are happening and start mapping things like workflow, people workflow to what we're seeing in the technology world. Because like I know like just from my experience, nurses tend to be creatures of habit, right? Even when you go and fix things in the environment, they'll still walk the same paths. They'll still skip the same areas that were dead spots before until they learn that they're now working, right? So there's a lot to be gained with something like that for sure.
Go ahead, yeah.
Quick comment, a bit of a side digression, nothing to do with site surveys, but when I heard that comment, my ears picked up and I thought, oh my goodness, cellular and our 5G LANs have another advantage that I hadn't thought about, right? Because they do define the client so well. They are able to do that. And you do get so much measurements. And over time, cellular has adopted a lot of the techniques from Wi-Fi, and Wi-Fi has adopted a lot of the techniques from cellular. And I'm wondering, will this actually start to become an issue for the clients on Wi-Fi? Is this something that we might see some pressure on to change and get some standardization that will force something back into the client? So something to look for, but another advantage for 5G LANs, I'm afraid.
Well, another thing I'll bring up, because to kind of move on a little bit from this location aware, is another big topic in the industry, obviously, is 6E. And we've seen and heard a lot about 6E-enabled access points and 6E technology here. Who wants to sort of give us the state of the state right now in terms of 6E, Wi-Fi 6E?
There's a lot of hype. We've been publicizing it for many years now. There's been many announcements about first to launch this product, first to launch this family, first to launch in this color. So a lot of different announcements there. We have a lot of infrastructure that can support 6 gigahertz. But from my perspective, the biggest thing that we're missing is critical mass on the client side. And until we have that, we can't really take advantage of the technology. And so customers trying to deploy access points right now need to decide, is it worth the investment to deploy APs that won't use the technology that I'm paying for, or will the life cycle be long enough that those APs will be in existence by the time the critical mass happens there? So it's part of it's hedging the bets that'll happen. There's some uncertainty when spectrum will be approved in different regions, right? So some countries are much further ahead of others with respect to completing the full 12 megahertz, implementing all the rules around that and making that happen. But it is relatively quick adoption. There are many countries jumping on board, at least pursuing a portion of the 6 gig spectrum, so that'll be there. But
you also have to share you're from Canada.
Yeah, so I'm from Canada, which coincidentally enough approved the 6 gigahertz band on the same day that 802.11x was ratified by the IEEE. Now, if that's not visionary timing, I'm not sure what it is. But there's that regard yet. But from my perspective, a lot of the critical mass adoption, really the mark in the line in the sand will be when the fruit company approves or releases a product that supports it. Until that point, it's neat to talk about, it's neat technology, but again, it comes down to critical mass adoption.
Not to mention the fact that at this point, we have very limited ability to measure 6 gigahertz RF from an enterprise perspective. We talk about designs and surveys and everything. We have all kinds of tools to measure 2.4 and 5 gigahertz, and we say surveys are important. It's really difficult for us right now to measure that RF and truly design for 6 gigahertz. There's a lot of estimation. We say, okay, 5 gigahertz will get you there. We know what the wall materials are. We can say 6 gig should be good there, but we're not there yet.
Yeah, I think we're gonna see a longer time frame with 6E adoption. This is my opinion, totally. From what I've seen, because of I think the biggest constraint is obviously you want the devices, right? But we've seen with previous cycles of wireless as it comes new, it takes a few years. Within a few years, you starting to see mass adoption of the new protocol. New phones, new laptops are coming by default with the new chipset, and so you start seeing the adoption go up. I think for us, there's a lot of supply constraints just around the world, just the chipsets, getting them shipped, getting them arriving somewhere so that, Aruba wants chips and other organizations want chips. The fruit company wants chips. Everybody wants chips. And, it's the whole supply chain. So I think not only do we have the normal, it's going to take a few years as the entire industry kind of coalesces around the new standard, it's also it's the supply chain. So now we have two things kind of working against us, plus the fact that it's brand new. It was only recently, approved, I think last summer, it was officially, 6E was officially approved. And AX was only approved last summer as well. So even that itself, it's been around for several years, but people are selling APs, but it only got approved. So I think, and we still have things that we're figuring out on 6E, like standard power APs, right? External antennas. We're still figuring out how AFC, the ability to coordinate frequencies, is working out. So I think there's a lot of things that are kind of gonna, it's kind of like molasses, like getting going. But I mean, I'm confident that obviously once we kind of figure these things out and get over these speed bumps, we're going to see a lot of great things. For me, I think the biggest benefit or the most exciting thing about it, besides just having much more spectrum, twice than what we have in 5 gigs, is really that it's going to be a greenfield AX environment. For me, that's like, okay, now is this thing actually going to work? Is AX actually going to be a thing, or is it a unicorn riding a donkey, like I've said? So for me, I'm really looking forward to see, hey, are we going to see AX become a real thing? And when I say a real thing, obviously we have it today. I mean all those features that were touted, OFDMA, BSS coloring, scheduling, all these things that we've talked about. Is it really going to become a thing? So I would love to see that.
I should mention that this afternoon Chuck did say that Aruba was working on a white paper, right, an update of their 14
yeah.
right? And I don't think there's anybody in this room that really doesn't want to see that. So we should pressurize him, get that out soon, build momentum for it.
Yes. I think I'll counter Eddie. I mean, I like a lot what Eddie's saying. I think we could be surprised. In fact, right now I'm surprised. A little earlier today, Dave Wright gave a talk on 6E, and in part of it he said that January of 2015 was the first time they met with the FCC. And 7 years later, we have shipping 6 gig product. Not only did it get past the FCC and the chip manufacturers made their chips, and we actually have products, both clients and access points, from ground zero, that we didn't even have frequency. So I am a little disappointed though. I thought when we got a new frequency this much, we would stop being backward compatible. The amount of, as Dr. Salter has said, Wi-Fi is not efficient user of spectrum at all. And it's sloppy. And we could have made some moves to a little more control over the discussion, over the conversations between transmitters and receivers. And instead we said, let's be like we used to be.
So 6E is AX only, but you're saying the protocol is still backward compatible.
Still has preambles.
So
it still has really long, slow stuff. It's still a CMA-CA.
Gotcha, right.
And yes, we might have OFDMA. We'll see. We don't have much of it now. And yes, we might have multi-user MIMO. We might even have upload. Who knows all these magic features. But Cellular's figured out how to make it work, and we could have just borrowed that.
Schedule everything out.
Yeah, we could have had it all much more controlled, and it would have been more efficient. And I'm actually a little afraid on the frequency side that the cell companies are going to come back and say, you gave them 1,200 megahertz. That's $1 trillion that we could have saved. Didn't the U.S. government want $1 trillion? And give it to us now instead, because we will be a better steward of this frequency and do more with it than you do. But we'll just charge everyone per kilobyte.
Well, they did that with the vehicular spectrum, right? That was allocated for that, so yeah.
But one other thing I think is kind of interesting, and part of it's related to Aruba's philosophy of customer first, customer last. They had potentially the opportunity to deploy 6E at this conference, but they chose not to do that because they have a lot of customers waiting to get their hands on APs, right? So that was one of the decisions why we don't have pervasive 6 gigahertz here. But there are a couple spots where there is 6 gigahertz APs deployed. But we were able to run a conference here where we set a record compared to the numbers attended in 2019. And it was a pretty good experience with respect to Wi-Fi. There's a lot of bandwidth, the different networking issues that did happen. But from an RF perspective, we're able to pass the traffic that we needed to on a 2.4 and predominantly 5 gigahertz network. So from this conference perspective, did we need 6 gigahertz to handle the bandwidth that we had here?
Yeah,
So
probably not.
Do we need
Well,
it right
I mean,
away?
if you
Like,
design
we
it
still
well
have
and
a
you
buffer of
share the
time
spectrum
before-
well, yeah, you're going to be good.
But there's hospitals I know of that could really use some dedicated spectrum to certain devices. And state, I mean, there's places where
Yeah, every stadium.
hotels and hospitality, there's a lot of places where having a dedicated spectrum to say, we really want this delivered. And we can pull that off with overlays with 6 gig, or we could go to CBRS. And Aruba's trying to do both, and all of us are trying to play in both places. But 6 gigahertz, that much spectrum allows us to do some of those things too.
Well, I completely agree with that. I think it's fantastic. I think 6 gigahertz is excellent, and I'm looking forward to moving there. I just think right now, at this point in time, you can always find some corner cases. Hey, we could take advantage of it here and there. But again, coming back to this conference where we had 3,500 people connected to Wi-Fi, we were okay on 5 gigahertz. So today, the immediate need for the significant amount of deployments to take advantage of 6 gigahertz, I don't think demand is quite there yet. But having said that, I think the sooner we can flip to 6 gigahertz, the better off we'll be as an industry.
Yeah, I just want to say I do work for Aruba, but I'm having this conversation a lot with a lot of my customers with, should I go with the 500 series or the 600 series? The 600 series is a little different than previous generations of APs where the 635 is really like a 515. So customers that are with a 6E radio, so customers that are looking at the data sheets, looking at, transmit receive chains, antennas, they're really asking this question. Should we, move to 6E, or should we, hope on OFDMA and multi-user MIMO, giving us those benefits that are great in theory, but in real world, they might not get you more capacity. Some of my customers that are really high bandwidth, they really want to go to 6E because they want that higher, they want to be able to run, 160 megahertz wide channels, and you really can't do that in 5 gig, right? Where 6E kind of opens that up to say, yeah, I know our marketing slide says whatever you can get for bandwidth on a 500 series AP, but you're never going to run that in 80 or maybe some sites, 80, but never 160, where 6E is actually giving them, the bandwidth that they're looking for to maybe, justify to the business using, maybe a smart rate port or a multi-gig port. But that's definitely a conversation that we're having with customers. And I am a believer more of, I think 6E will bring us more benefits in the long term just because of the additional spectrum, which, is more of, I believe, a better bet than hopes of own OFDMA or multi-user MIMO. So
Just a question of curiosity. Who here on them has a 6 gig or a 6E capable device?
Keith.
And I only have it so I could answer that question.
Right. So
It's only for testing.
Are we talking
Even if we
about
deployed-
access points or clients?
No,
Clients.
Clients, yes, okay.
Yeah, so even if we had the infrastructure here, Keith is the only person who had the forethought to bring a device that actually could connect to it. So
But I
I think
think-
just going back to that critical mass.
But I think that what he's referring to, though, is that, and this happens every refresh cycle. It's like, should I go with the new AP, right, the one that has a 6E, or should we just stay with what we have, or stay with this technology? And I think, I don't know, I mean, it's not an easy question to answer, but I think if you're doing a refresh cycle and you have the new APs, you have the budget, get the new APs, right? You may not be able to use the 6E, but they're going to be new. You're going to have new chipsets. Even if you're not using the 6E now, the 5 gig will be better. You're going to have better receive sensitivity and different things on the technologies on the new APs that are just not available on the old ones. So there's a benefit there. And when you start rolling out the 6E, now you're going to have the 6E. So in my opinion, it's like if you're doing it anyway, if you're getting new APs, might as well get the 6E ones. Now the other thing too is that is that a lot of times when the new APs are coming out, and like you said, like the 635 kind of is the equivalent to like the 515, and oftentimes, you know, price is usually similar because they want you to move over to the new one. So I mean, if you're doing a refresh and the cost is a little percentage more maybe or the same, why not? Then it's there and it's available for you to use.
My question is, when we think of IoT devices, we typically think of 2.4. Do we think that those devices will start to grab onto that 6 gigahertz spectrum?
Oh, sorry, I shouldn't have laughed.
A lot of the drive in IoT, it's bandwidth constrained and battery power constraints, right? And one of the advantages of 2.4 is that you can you end up transmitting further, right? And so we all know physically there's some physics rules going on there, but due to the nature of the size of antennas, you can propagate further, which allows you to turn down your transmit power. Also, globally, there's a lot more support for the 2.4 band. Whereas if you look at 5 gigahertz or 6 gigahertz, it's pockets of different frequencies that have different support. You have to add more antennas, do more scanning, which then consumes more power. So I think from an IoT perspective, just because of the constraints that kind of come along with that, I think 2.4 still remains quite attractive, but potentially moving up to 8x capabilities still within the 2.4 band. And then the more devices, we can move to 6 gigahertz, right? 'Cause I think that's definitely the way to go. Don't get me wrong on that. 6 gigs is the way to go, but the more devices we can move to 6 gigahertz frees up spectrum that IoT can take advantage of. Because usually it's not transmitting in time-sensitive transmissions, so it can wait a little bit to squeeze its frames into the airwaves.
All right.
Just to build on that a little bit, sorry. You know, because is the leveraging off the OFDMA in the 2.4 is actually a critical component because you can use a smaller resource unit, so you're not going to suffer so much interference from other devices operating in that band, and you're also not going to consume as much power. So it's a really nice solution for an IoT device in the 2.4. It starts to look, you know, like a device, same bandwidth utilization that you get with Zigbee and Bluetooth, for instance. So you can get the same power advantages.
I see a lot of IoT vendors, though, staying with even cheaper 2.4 chipsets.
Yes.
And even, not even AC, let alone
Going
AX,
OFDMA.
just to keep the price down.
Yeah, and I've changed my opinion over the years about that. You know, as a wireless guy, I'm like, why are you on 2.4? You should be on 5. You know, there's more bandwidth and all channel reuse and things like that. You can get faster data rates. But to Troy's point, what I realize is, oh, wait a minute. Yeah, the chips may be cheaper, but I have a feeling that as far as IoT as an industry, I think they've realized that, as Troy said, 2.4 for what they're doing is the better option, right? You get better propagation through stuff, and it's cheaper. And if I don't need to send hundreds of megabits of data, if we're just doing an update, hey, this is what the temperature currently is, or someone just walked across your front door or something, you don't need high throughput for that, right? You just need, you know, the data just needs to get through. And so 2.4 is again, I think I understand now. I've changed my mind. And now I've also thinking about how Wi-Fi works, only one device can talk at a time, all those kinds of limitations. Hey, if I can get stuff off of my 5 gig, printers, IoT, anything that doesn't require high throughput, put it on 2.4, that leaves more airtime for me to use on 5 gigahertz, right? So for me, I actually do like the idea of IoT devices on 2.4. And that's been a change for me. When I first started thinking about it, I was like, why are they all on 2.4? Why is everything 2.4? And I realized, oh, I think that's actually a smart move.
Maybe rewinding a couple of questions back, which is 6 gig motivation for that. So I just want to maybe tie it back to the earlier topic we had, location. So from an infrastructure point of view, the other advantage of 6 gig is that allows the access points to actually use the 80 or 160 megahertz for ranging purposes. So there's definitely added value for the AP to be 6 gig capable, so we can actually leverage that even while the clients are making their way on to supporting 6 gig. So that's just a thought.
Can I ask you how that, why a wider channel is better? So the frames that would be used, I guess, are they actually data frames that are sent for a location? So they're using the whole channel width, not just the primary channel?
That's correct, yeah.
Okay,
Yeah.
so because you're listening to more spectrum, you can get a better reference.
Yeah, I think the
Gotcha.
time,
Okay.
yeah, exactly.
So
yeah.
wider channels, in this case, are more beneficial for location.
Yes, for ranging, absolutely.
Okay.
Yeah.
Excellent.
So getting back to what you had mentioned about steering some of, printers and some other devices to 2.4, I had a thought once, we get 6E clients and stuff like that, is to have the ability to, tie it into like ClearPass or a radio server of some sorts, and then be able to do like frequency selection, push that to the controller, so then they can steer them to the right band. So like if you see printers coming in and authing, whether it's a Mac auth or whatever, you detect that and be like, well, it's a device that we don't really care about. They don't need a lot of bandwidth. Let's just steer them to 2.4, or you got some, say medical telemetry devices, and you want to push them to 6. It'd be kind of a cool feature, wink, to add into ClearPass to kind of be able to steer clients towards a specific spectrum.
My hesitation with that is, my preference would be if you want a device to be on a band, give it an SSID that's on that band only and connect to that SSID. The reason is because things like band steering, there's the two main ways you can do it is proprietary, right? Which not every device is going to like. And then the other one is standard based, like 802.11v. But things like printers and things like that probably don't support 11v, and so you can't tell them, hey, go here. So I think if it really matters, if it's something that's important to you, I would look at manually doing it. Hey, if you're a printer or whatever, we got a printer SSID just for you that's only on 2.4, and when you connect, that's the only option you get. And since that SSID doesn't exist anywhere else, you're not going to roam. We don't have to steer you. So that's my only hesitation, is just devices do what they want to do, regardless of what the infrastructure says. One device A might say, oh, sure, no problem, I'll go over there. And the other device will say, nope, I want to stay here, and I'm not going to move no matter what you say. So in those kinds of scenarios, my recommendation would be just give it an SSID on that band only, and you'll know it'll never move. It'll always be there.
And I know a lot of IoT devices or a lot of IoT implementations have a single 2.4, channel for IoT, and that's it. That's the
they don't
SSID for
support
IoT.
any features or, they don't, very basic stuff.
Yeah, thanks. So one consideration I was going to raise that I know some of our customers are thinking about when they think about making a transition to 6E and what's the timing for that, is their assumptions about Wi-Fi 7, both in terms of how long it's going to be and what it's going to bring. And we had been telling a story for a long time that Wi-Fi was becoming more efficient and more like cellular networks, and the OFDMA was a big part of that story. So if you wanted the infrastructure to have more control over access to the medium, we were on the right path with Wi-Fi. I think that's very much the case with 11AX. Unfortunately, for a lot of reasons that maybe you want to discuss, that's not going to be the case with BE. None of the features that I think should really be important to the enterprise that we had proposed and others had proposed, and we and Cisco have both blogged about this, none of those are going to be part of the standard as it looks right now, and the chipset vendors are committed to the standard that it looks right now. So if you're thinking about, do I upgrade to 6E now, thinking that in 2-3 years I might want to upgrade to 7, that dynamic looks different if you don't think there are any enterprise features in Wi-Fi 7, or if you think Wi-Fi 7 is going to take longer to get going. So we think 6E has legs for a long time. You're not making a decision for 2022, you're making a decision probably that will last you through Wi-Fi 8.
Yeah,